Good afternoon. Good afternoon, ladies and gentlemen. I know it's difficult after the lunch to focus a little bit, but we will try to entertain you till the end of the sessions. First of all, I would like to thank the organizer of inviting us to this conference. I remember last year we were about 40 people, and today we have about 240 people attending this conference. It's really impressive. My name is Slavco Velickov. I'm based in the Netherlands, working for Bentley Systems, US-based company. And by landing in Dansk, it's exactly copy-paste in Amsterdam. So I wonder whether you copied the city or the Dutch copied the Dansk city. Nice canals, nice landscape, and also the house is exactly the same. So my topic of the presentation will be the following. I will introduce a concept which is called BIM, Building Information Modeling, for delivering projects in stormwater infrastructure. Of course, hydraulic models are important for designing, planning, optioneering, but also asset management of the stormwater infrastructure. Some examples, projects, and of course, some conclusions and discussion. First of all, who is Bentley? Bentley Systems is an international US-based company, about 3,000 employees, delivering technology for planning, designing, and asset performance of any type of infrastructure, including water, wastewater, stormwater, but also anything which is with infrastructure in order to improve quality of life. Now, what we call in Bentley, we have a range of technologies, and for certain projects, like today we are talking stormwater infrastructure or also sewer infrastructure combined, we call that project playbook. There are certain technologies that can be used to design, rehabilitate, plan, costing, of course, but also asset performance management of this infrastructure which is developed. And we are covering basically virtually anything, covering the complete urban water cycle, but also rails, roads, offshore, onshore, etc. We've seen many presentations focusing on the drivers for why we need space and time for stormwater. The reason is, of course, I will not repeat it, climate is changing, population is growing, we know all this stuff. And we try to develop or design blue-green infrastructure, but also I would add here blue, green, and gray infrastructure as well. So in Bentley Systems, we are looking holistically, and in the middle, as you can see, there is a digital information model. I will come to that many, many times in my presentation just to enforce the concept of BIM, Building Information Model. What is Building Information Model? On the X-axis, you see, for example, project delivery. We are constructing a new retention area. We are putting an underground storage tank, for example. We are expanding the stormwater network. So this is a project or set of projects aimed to develop sustainable drainage systems. So that's project delivery. On the Y-axis, you see asset performance is coming in place. It's not just the project, but how we are operating and maintaining the infrastructure in the future. That's becoming very important. And on a project delivery side, the better, let's say, project delivery is aiming at information mobility. So the project that you deliver can be used by many consultants. The owner of the infrastructure can be used this project in the future to maintain and operate. But of course, information modeling is becoming very important. And we see advancement in both CapEx and OpEx. We call it, of course, TOTEX. So while you are designing and rehabilitating an existing infrastructure or designing completely a new stormwater infrastructure, TOTEX must be taken into account. Not only the capital expenditure, but also the operational costs. Why this is important? This is a well-known slide because of the 80-20 rule, of course. I mean, we spent maybe 20% on business requirements, optioneering, designing, checking different scenarios, finally construction, of course, where the most of the majority of effort goes, but we forget the life cycle of the infrastructure. The stormwater infrastructure is there to stay for 100, 200 years, and so forth. So investment in the operation and maintenance becomes very critical. And that's why we are advocating from the beginning to look at this. How can we look holistically? It's basically looking at BIM, Building Information Model. It's not about this building, but anything which is built infrastructure. So why BIM? BIM is important because you are delivering two deliverables. One is the physical infrastructure, which is the pipes, storage tanks, pavement areas, green roofs. This is the physical delivery to the contractor. Or the other delivery, which is very important, is the digital information model. Digital information model is becoming critical. Why? We have seen some technologies, for example, from the previous presenter. We need to put sensors, we need to know where are the manholes, we need to know where are the inlets, and we need to know how we are going to maintain this infrastructure in the future. There are different levels of BIM, first level, second level, third level, etc. I'll not go in details. And also this BIM is coupled with the asset management standards. Like many of our companies that we are working for, let's say, certified on ISO 9000, ISO 14000 for sustainability, etc. In near future, not close future, I would say, because this is a driver now in Western Europe, it's basically certification of ISO 55000, which is the asset management standard, in fact. So I'm coming back to these digital engineering models. We have many components while designing a new project. Can be network models, for example, can be 3D models, schematic drawings, pumping stations, etc. Analysis, hydraulic analysis, structural analysis, functional components which are installed there, real-time controls, SCADA systems. And at the end of the day, everything is about this digital information model that we create. And this is a living organism which is basically presenting the reality. BIM level 1. It's basically, we are all familiar with the BIM level 1. We have done it. AutoCAD drawing, microstation drawing, for example, model, network model. This is a civil storm that I'm showing on the screen. So we can design something in 2D. Also 3D design. This is 2D design, for example, storm drainage network together with the catchment areas, and we can check capacity, we can check different structural and non-structural measures in the infrastructure. 3D design, like this, for example, making it more intelligent in a reality in order to check clashes with the other infrastructure, in order to cost the model, for example. If you open up the street, you know where is the inlet and where is the manhole. So this is BIM level 1. BIM level 2, we are going to add fourth and fifth dimension, not only XYZ coordinates, but we are adding time. We have seen why the time is important, the tension time and the storage in the stormwater systems, and costs. While we are designing or rehabilitating a sewer drainage network, we can add the costing of the system as well, so we know what is the CAPEX, OPEX, and the TOTEX expected in the future. So this is BIM level 2 that we are calling it, including construction modeling. Why this? For example, this is a small movie showing you installation of, for example, storage tank. You can in real time simulate, once you have the information model in 3D, what will be the clashes with the existing infrastructure? How I'm going to install the underground storage tanks, for example? Well, the clashes will appear. How it will connect to the pumping station or to the valve, etc. So this is just to show you that having this building information model digitally, you can do many, many things, and this becomes a sort of a living organism. Finally, what we are aiming is BIM level 3, information model, which will serve to improve the performance of the assets in the future. Take a sewer or a storm drainage network, which is a combined or separate. We have a lot of inlets, of course, but we don't know what is the capacity of the inlet. We don't know how much leaves they have, for example. What is the sediment transport? So this asset performance is becoming very important. And there, seventh and sixth and seventh dimension can be added, like maintenance and operation, procurement, life cycle engineering, inspections, etc. So this is where we are aiming with the development of the technology. And needless to say, everything needs to be geo-referenced. We have to know the exact locations in millimeters of all the components of the storm drainage system, which becomes important. And finally, of course, Bentley is putting a lot of emphasis on these reality models. We want so much realistically to present the drainage network such that, for example, we have developed a technology which is called context capture, which is very interesting for overground and underground infrastructure. You can fly drones, you can take photos with your mobile phone, etc. And then finally, you can reconstruct 3D models out of pictures, which are photorealistic and very accurate in a way. So if you don't have a 3D model of the urban drainage system, you can reconstruct it with drones. This is an example of how this technology works in inspecting large mains, combined sewer system, for example, in Paris. It's mounting a camera, high-speed camera, 360. Then the camera is just on a rail. You take pictures, and then finally you get a photorealistic representation of the complete collector mains, which are critical for the sewer and the stormwater infrastructure. What is their conditions? What is their effective diameter, etc. Sediment transport and why use, for example, this type of technology, playbook, as we call it, Bentley playbook. Different technology can be used for different purposes. Capacity is important, master planning, force mains, flood risk analysis, like we saw the city of Arnus in Denmark, for example, and many, many other things. What I want to mention here is that in order to enable this type of technology to exist, you need to map, basically, the existing infrastructure. For mapping the existing infrastructure, Bentley has some technology which is called open utilities. And a good example is basically water utility here in Gdynia, which is using this technology to map in 2 dimensions and 3 dimensions their stormwater and sewer infrastructure. What is new basically in these software packages is we have seen a lot of constructions, but there should be a fine balance between hard engineering measures and also the soft engineering measures, as we call it, by putting a low impact development components. For example, creating a grass instead of an asphalt pavement areas, creating green roofs, creating storage areas, underground tanks, for example, like Mr. Wojciech was presenting with a boomerang application. So these are solutions which can effectively detain the water much more efficiently than constructing a floodgates and constructing a big engineering work. So this is, for example, an example just to show you a couple of things. I'm not going into detail, but infiltration here can be, up to 60–70%, and the water is detained in this area and then released gradually when the rainstorm event is gone. This is an example of the storage tanks we have seen. Now, what is the purpose of all of this? Is, of course, cost-effective design and rehabilitation. The outcome should be optimal design, minimized capital investment, but I would say minimized TOTEX. It's not just the capital investment we're investing. That's why I'm talking a little bit philosophy of a holistic approach, the building information model. The TOTEX should be optimized, the total life cycle of the infrastructure. Design of new infrastructure can be done by the software tools using, automated design with constraints, putting slopes, putting corridors into the consideration, etc. Existing infrastructure, also evaluation of capacity, evaluation of risk of flooding can be done by the software tools and identifying basically the bottlenecks in the system and where to act.
Connecting pipes.
This is just a small presentation to show you how interactive design can be done in 2D, 3D, and running optioneering, as we call it, different scenarios. So interactive design in a way, and you can compute in a real time, basically. So this is the digital terrain model, 2D, and immediately you see it in 3D.
You'll notice here that I can also reconfigure the pipe network itself simply by dragging the pipe connection points. Now, what I want to do now is I'm going to zoom into a different portion of the same project. I've moved to a different intersection, and so what I want to do here is I want to reposition this catch basin that's along the main road.
This is an Australian accent, by the way.
To help me position it at the end of the curb return.
We will not go through the complete movie, but just to show you that we have a technology that is beam ready. So while developing and designing this storm drainage network, you basically deliver a beam ready model.
Now I want to extend
one of the messages here is when the infrastructure owner, like for example Gdańsk Water or Gdańsk Melioracji or Gdynia, etc., is asking the contractors to deliver a model. 2D drawings are not acceptable anymore. You have to deliver an information model which can be used later on for any type of asset management purposes. Several also presenters show that re-evaluation of the flood risk is critical for our infrastructure. We don't see events, for example, in the statistics that we have for 100, 150 years. Sometimes we see rainfall events, convective rainstorm events, typically, happening during the summer period, which are very heavy, very intense, and their statistics fails to give us an answer. So that's why we need to re-evaluate and remap the flood risk for different scenarios that we never saw before. So flood risk mapping is a very important two-dimensional, three-dimensional, and I want to show you one movie here, how, for example, for the public, if the colleague can play the movie. This is an example of flood risk visualization that is done for the city of Paris, pluvial together with fluvial flooding, so river together with some heavy rainfall event. And Bentley has a technology which is used in Terminator, which is used in Avatar, for basically putting all the information together and creating realistic scenarios. So the stakeholders, like people, managers, investors, can see what will happen, what is the scenario, for example, and where the water will go on the street, which objects will be under risks and threat, etc. I'll just let the movie play just to show you. And this 3D model is not necessary to have it. You can develop it from, basically from drones, technology that we show you. This is Louvre, of course, the famous museum, and this is the maximum water level that you can see that may occur once in 100 years. This photorealistic scene, we put in cars, animation, people. And you can see what will be the depth of the water, basically, at that point in time, the maximum water level, whether our house will be underwater or not. So this is new way, new tools that's why I'm showing you, having this information model from the storm drainage network, having the 3D city model. It's possible to do much more in order to show and demonstrate to different stakeholders. Finally, I would like to, this is just a small snapshot. If you want to know about these technologies, my colleague Jacek is here. We are there having a small stand. So if you want to know more about the technology that we are using, for example, here in Poland and also internationally, for creating this type of information models, I would summarize my presentation that I've shown you a new approach, which we call BIM, Building Information Model, of delivering digital information in storm, sewer, water, or any type of infrastructure. The modeling products are critical. Evaluating options, scenarios in 2D, in 3D, etc., are very important because they are representing the physical movement of the water through the pipes on the street, etc. But finally, to reinforce the messages, there will be no more acceptance. Like, for example, Crossrail in the UK, the Dutch government is not accepting any more drawings. 2D drawings are unacceptable. Delivering the infrastructure plus delivering an information model is the future. So that information model becomes operational and ready for asset management in the future. So I would like to thank you for your attention. If you have any questions later on, we can address it.